Okay, let's start with a straight current carrying conductor. The current goes in this end as indicated by the arrow here and by the X on the end, and the current comes out of this end indicated by the dot. Surrounding the conductor are the magnetic field lines, which indicate that there's a field here. The field is everywhere, strongest around the center and weakest on the edge. We represent it with these lines every now and again, rather than, you can't really have them through the whole field. It would just be a sort of cloud that was dense at the center and faint on the outside, and you would no longer be able to see the direction. This follows the right hand curl rule, with your thumb pointing downwards in this case and your fingers curling around to show the magnetic field lines are in that direction. If we curl this conductor into a loop like this, and you follow still with your thumb pointing this way at any point, pointing along the arrow and curling your fingers would always curl inwards from this side and out that side, and so you get this sum effect where all the fields created from all the way around the loop, and obviously it's not a physically possible loop because it wouldn't be connected to a power source, but if you could have power running through this, then you would get this effect. And if you show more of this, you can see that it happens all the way through, and you end up with a very strong field in the center as all the fields add up pointing through. If we coil this loop a few times into a coil, or a solenoid as it's called, then you get this effect. It's still the same as a loop, except you can imagine just lots of loops next to each other, and if you show all of them you get this. So it's very strong through the center with all the fields adding together, and the more coils you have, the more of this effect you get.